Okay, so chapter 10, section 4, we're using square roots to solve quadratic equations. So you did a nice job yesterday, and today we're going to see more sophisticated equations. So you can see there's more going on. So the goal of solving equations using square roots is to isolate what? Isolate the squared term, right?
Yeah.
Okay, so we have a larger squared term in this problem. And so we're going to isolate the big squared term rather than just an x squared, right? So how do we do that, Kelly?
Well, at first you want to solve it.
We want to isolate the squared term.
You're going to do the exponent first.
Anyone have another idea? How can we isolate the squared term? Talia.
You have to square the x to 6.
You might do that. I mean, that's like the first thing people think, because that's a square of a binomial, right? It's going to give you a perfect square trinomial. But this is something different. Jocelyn. Excellent. Divide by 4. And when you do, we have this expression that's the squared binomial equals now 8. Okay? So, what can we do now? JD? No, we're not. Because we're using square roots to solve. So we have our squared term isolated, so we
find the square root.
take the square root. Good, right now. Take it right now. So we're going to take the square root of this large expression, and guess what? The square and square root are inverses, so we are left with what is inside those parentheses. Isn't that nice? X plus 6 equals, now we have this, unfortunately, irrational number. Oh well, we can just call it the square root of 8 for now. Now, is the square root of 8 have one solution, two solutions, or no solution?
One solution.
1, 2, it would have 2. It would have a principal, positive, and a teacher. I mean negative, just kidding. A principal is the positive solution, right? And then the opposite of the negative. Okay, so how would I get x alone now? Lauren? Subtract 6. And so we have x equals negative 6 plus or minus the square root of 8. Now, could we estimate the square root of 8 or find it using a calculator?
Yes.
Approximate it? Yes. Or in many cases, we leave the radical in simplest radical form. So what is simplest radical form? Do you remember what you have to do to get a radical simplified? All right.
Isn't that when you split the parts?
Yeah, are there any what's inside the radical? What is it we try to get out of there? Perfect squares, right? Are there any perfect squares in 8?
Yes.
So let me write this out. We would have square root of 4 times 2. So good, you're thinking take the square root of 4 out. So we have negative 6 plus or minus 2 times the square root of 2. Okay, or, of course, we could give an estimated value of the square root of 8, which is probably what they're doing. That's what they're doing here. So it's interesting. There are many ways to express things, but if we wanted to, let's back up to this place here. X equals negative 6 plus or minus the square root of 8. We've taken the square root of 8 already. We've approximated it just yesterday, I think. The square root of 8 is not quite what perfect square? Square root of 9, right, which is 3. So it's just under 3, and so our estimate is 2.8, and that's what we used yesterday. So we could now say this: x equals negative 6 plus or minus 2.8. So what would the two values be? If I had negative 6 plus 2.8, what do I have? Or if I have negative 6 minus 2.8, that's the easier one, isn't it? Negative 6 minus 2.8 is just two negatives, add them up, and that's negative 8.8. Negative 6 plus 2.8 is as though you have to subtract 2.8 from 6, right? And give it a negative. So we're going to borrow, and we have what? 5 minus 2. So negative 3.2. Okay? So again, we would expect two solutions because we are taking the square root of a positive. And so those are x-intercepts. Halfway between those is an axis of symmetry. You could fold the parabola on. This is a quadratic equation, so it's a parabola. Okay? Any questions so far? We'll practice here. So let's practice a few more. There are 3 questions here, so pause and give it a try. And again, round it. Let's round these to the 10th place. Okay, so shall we try the first one?
Yeah.
Jack, what would you do first? Okay, so he says divide by 2. And we have... And what would you get?
X minus 2 equals 3.
Wait a minute, just 3? Good, plus or minus 3. Okay, and then what do we do to isolate x?
So then add 2. So then it's x equals 2 plus 1 is 3.
Okay, so tell me our 2 values. What is 2 plus 3?
6.
2 plus 3. Or 2 minus 3? Negative 1. Now, keep in mind, you can go check this in the original equation. Let's go plug in 5. What is 5 minus 2? 3. And 3 squared is 9, and 2 times 9 is 18. Okay, let's try the negative 1. Negative 1 minus 2. Negative 3 squared? 9 times 2 is 18. So again, you have every chance to check your work as you go. So I hope you do. Okay, so this is a different problem over here. We're starting on number 11, and Jocelyn's going to try it. Don't put your wrist down on it, okay? If you put your wrist down on there, you know what I'm saying? I think it was having a hard time finding it. Oh, where'd it go? There you go. Okay, she's trying it with the stylus. Okay, good. Did you do 28 divided by 4? Oh gosh. Here, let me do this and just erase one little piece here. We're going to the 10th right now. Go ahead. Not quite. 28 divided by 4. 4 times...
Oh, it's 7.
7. What did you forget to do to both sides? This is q minus 3 squared. Okay? So what do you have to do to both sides? Good. And you have q minus 3 equals the square root of 7. Good. Q equals 3 plus or minus, good, square root of 7. Okay, and what is our estimate of the square root of 7? We just had the square root of 8, which we said was 2.8. Who says 2.6? Sounds good. And we could check that with FDAD or with a calculator. Square root of 7. 2.6, good job. Okay, so show us the 2 values then. If we use 2.6 to the 10th place, we have, go ahead. You're going to have 3 plus or minus 2.6, right? Is it not working?
Can I do the next one?
Okay, so there we have it. the two solutions. And we're going to back up and see our final question here. And I think we'll do it a little faster, oh goodness, by not using the iPad for a second. So go ahead, if you are watching this on video, and pause and come back and check your work with your final work shown. Okay, so there we have two solutions, negative 7.8 and negative 2.2. Again, this is a parabola, and we end up with 2x intercepts, okay? We're just looking at this real world problem. Once again, because we're dealing with quadratics, we're going to see the vertical motion model again and again. This is kind of a fun thing. At an ice hockey game, a remote control blimp is flying along, and it drops numbered table tennis balls out of the basket. And so they just press a button and it drops the tennis table, a ping pong ball, okay? The number on the ball corresponds to some prize. So here it is, dropping. So we're using our vertical motion model. So you may see in today's assignment our vertical motion model. It's just the most common quadratic equation that you are expected to be able to use, right? Now, what do we know about dropping things? How is that different than throwing things? JD?
Because you're not like throwing it, just drops.
So what part of the equation isn't in a dropped? The V part, good. So you'll see today, if you are facing a problem where things are dropping, the initial velocity is 0. So we're going to probably see that today because we're solving by square roots. And there's no middle term. So this is a great equation to use for real world problems today. Okay? So we won't bother with that. If you want to look at it up close, you can see it in your book. There you go.